listing and figures. So this is the analysis part which we are going to create the specific tables based on the SAP requirements. Okay. So as you are aware, right, we are going to create the Adam data sets, which is nothing but the analysis data sets is meant for only creation of the TLF part. Okay. So what is there in the TLF part? Obviously, what kind of outcomes we have in the study, like is a primary objective, secondary objective, okay, like safety and then efficacy endpoints. Okay, these all are the things. Okay, so to prove the regularity authorities or any other specific bodies, okay, so they will analyze the data and then provide the some descriptive and the categorical and continuous stats. Okay, so based on the TLF outputs results only, they can decide that whether the drug is efficient or whether the drug is safety or like what kind of things. Okay, they will come across the TLF results. Okay, so based on the TLF results only, they'll write the CSR report, the clinical study data. So there's a final one. Okay, so in terms of the tables, okay, remember the tables looks like similar for the all studies, but remember each and every study will not the same requirement, same thing. Okay, when it comes to the programming part, okay, the things will be repeated. Okay, but when it comes to the stars in the TLS representation, the study to study vary. Okay, so but however, as you all aware that the things and then the steps which we need to follow and then what are the documents involved in the TLF generation that you have to understand clearly. Okay, so remember, as you all aware that while we working on the Adam dataset, we discussed about that. Okay, these datasets, the derived variables we are going to create in Adam level based on our TLF requirement. Okay, it means okay. So what are the derived part and what are the things which we are going to utilize in the TLF part that we already did in the Adam level variables. Okay, so now we need to understand how the shells are looks like, and then from the shells point of view what are the things each and everyone should aware. Okay, that we are going to discuss. Okay, so whenever you open the TLF shells, we can say the TLF shells or mock shells, whatever the may be, the both are same. So the people, few people will call that TLF shells and then few people will call that mock shells. Okay, whatever it may be. So the shells looks like here. So the list of tables. So the basically remember the TLFs will have only in one document, but here we have the three different documents in the real time. So these all the tables, listings, figures will be there in only one document. Okay. So that will be mentioned clearly in the table of contents. Okay, like the list of tables, how many tables. Okay, if you can see this is the table number. If the table number should be unique, it should not be repeated anywhere. Okay, but the series of the tables, okay, the similar kind of series tables will have the same series. Okay, for example, if you can see 11.1.2, 11.1.3, 1.4, if you can see here, okay, so the adverse event related is 11, 3, 1, 1, 1, 2, 1, 3, okay, 1, 4. Okay, these all are adverse event related TLFs. That's why they have used the same kind of series. Okay, so if you go little bit down, okay, these are the one of the subject disposition table. Okay, so this is the mock shell. It means so the based on the mock shell we have to create the table based on our existing data. Okay, so that we will discuss in detail. So before that, okay, we have to understand what is the TLF shell and then how it looks like and all these things. So if you can see this is the table, this we can call it as the title or header part. Okay, so this, okay, if you can see the table title, table 11.1.1, the subject disposition is the table. And then whenever you okay, whenever you see each and every table in the bracket, there will be something they'll mention. Most of the cases here the population flags. Okay, so for example, if you can see here they mention this all subjects. Okay, which is nothing but who all are participated in this study, all the subject data need to represent in this table. Okay, so for example the subject disposition for the all the subject. Okay, the next, this is also header of the table, and then these we can say each and everything is a header count. So header counts, this is nothing but header counts are begin. Okay, these are the headers. Okay, So the drop treatment XX, treatment XX 01, 02, 03 or whatever it may be based on the study requirement and all the subject total drug. Okay. So these will be the table headers. And then n equal to XX, this is nothing but your begin. Okay. If you can see all the headers will have the begin value. So the begin is nothing but the count of the particular group. Okay. So if you can see, these are the table body of the table, and then we'll have the different categories and the respective count and the percentage. This will be the percentage, this will be the count. So this count we can call it as a small n. Okay, this is the big N, and then this is the small n. Okay. So whereas this percentage comes from this small n divided by big N into 100. Okay. So remember, these percentages will comes based on the this small n divided by the respective big N into 100. This is the general assumption for the most of the table, remember. But it will not same for all the tables. Okay. So for example, some of the tables, okay, so they mentioned these are the categories. Okay. So in the categories there might be a subcategories. Okay. So in that case, for the subcategories, percentage based on the main category means, for example, let's assume this is the main category, these are the subcategories. Okay. So these count, for example, here we'll have the 10. So out of 10, the subcategories, so the one of the category will have 2, one of the category will have 3, and then depends. So in that case, this small n divided by this n into 100, not this n. So in that cases, okay, the percentage how we can identify, that will be mentioned in the footnotes. So this we can call it as a footnote. This is the header or the title. This is header, and then this is the title, and this is the footer or nothing but the footnotes. So if you can see, the percentage will be number of randomized, that is used for the all percentage calculation, which is nothing but big N value. If you can see, this is the treatment values. Okay, the randomization based on the treatment, right? So the treatment number, okay, which is nothing but the small n divided by the big N value. Okay, so that's what they mentioned. And then in the footnotes they can mention the some abbreviations. For example, if you can see the if you can see the subject enrolled, in the bracket will have the A means informed consent received. So enrolled subject is nothing but who have signed the informed consent. That subject we can call it as an enrolled subjects. Okay. So in the footnotes, okay, why? Because who has reviewing this table or this particular outputs. Okay. So the FDA reviewer, regulatory authorities, or the sponsor, or the some X person, they might not aware of all the things. So that's why we need to provide the proper information for the particular table. That's why how we have calculated the percentages, and then is there any short forms abbreviations that we can mention, and then is there are any specific uh, derivations which we did in this table, that derivation logic also we can mention, but not entire logic. So these are the tables we consider something like that. Okay. So it means whenever the reviewers review the tables, okay, they should understand the what is what. Okay. Now, so far is that clear? Have any questions? Yes. Everyone. Okay. So some of the quick checks. Okay. So this small n value should not be greater than big N value. So the why? Because this is the main count. Out of this, for example, we'll have one class. Okay. In the class, there will be 100 students. Okay. So out of 100 students, okay, the 70 members got like first class. Okay. And then some 25 members got the second class. And then remaining 5 members got third class. Let's assume. Okay. So if we sum it up, the first and second and third class, it should be equal to or less than your class strength. What is our class strength? 10, 100 members. So whenever we have categorized with the based on the how they passed, like first and second and third, so that count should be less than or equal to, but it should not be greater than, right? Why? Because we have only 100 students. How come with the all the classes we'll club it and then we'll get the 100? For example, so the main count is 100, and then first class is a 70, and the second class is a 30, and third class is a 5. What is the count? 1 at 5. But actually we have 100 students only, right? So that is a wrong thing. So the same like here. So what is the your total count? For example, big N counts, and then that should not. I mean, this small n should not greater than this big N. Okay. So there will be some few tables like the adverbs that might have the small n compared to the big N. Why? Because there we are talking about the events, not the subject counts. So whenever event counts means the same subject we may get the more than one event, right? So let's assume here we have the 10 subjects, but here we have the one of the adverse event, okay, like headache will have the 25. Sorry, not, I mean, for example, cardiovascular disorders, okay, this will have the 25. How come the 25? We have the only 10 subjects. How can the 25 number? Why? Because these 10 subjects might have the multiple gastrointestinal disorders. So the count of the event might be the 25. You got it? Is that clear? Hello? అర్థమైంది అందరికి? Is that clear? Yeah. Okay. So next, and if we can sum it up all these, that should be equal to your total value. Okay. So this is the total randomized subject. Out of randomized, how many patients were dropped? How many patients were randomized to the XX? And then how many patients were randomized to this treatment and this treatment and this treatment? So if you can club it all these, and then it should be equal to your total value. Okay. So this is about all your the table. Okay. So if you can see the second table, so demographics. Okay. So the demography, if you can see this. The 11.2 table, this is the title of your table, and then we have the treatment 1, 2, 3, let's assume, and then all the treatments. If the first is the age, okay, so age is the numeric value, okay, which is nothing but the continuous value, okay. So there we can get the counts, okay, and then descriptive statistics, which is nothing but is the okay, continuous starts. What is the continuous starts? N, mean, standard deviation, median, min, and max, which is nothing but in the age. What is the, okay, so for example, in the study we'll have 100 subjects. Out of 100, let's assume that we can consider these 4 treatment. Here the 25, here the 25, 25, 25, let's assume. So out of 100, what is the n? N is nothing but non-missing values. How many subjects will have the age present? So out of 25, every subject will have the age, then we'll get the 25 year. So for example, out of 25 subject, there is one subject age is missing. Then you will get the 1 year, 24 year, and then one will be missing. Okay. So the mean is nothing but what is the average age. For example, one subject will have that one, let's assume that 45, one subject will have the 40, one subject is at the 50. So what is the average age? We can say that 45. Likewise, how many subjects will have, what is their ages, based on that, this is the average value. And then this is the standard deviation, what is the mean value, median value, which is the minimum, median value, what is the minimum age, what is the maximum age. Okay, so like, so how we can get this starts? ఎట్లా వస్తుంది స్టార్ట్స్ ఎట్లా తీసుకోవచ్చు మనం? Hello. Because age, we have an age variable, so we need to get the descriptive statistics for this age variable. Then how we can get these descriptive statistics? No వన్ నోస్ ఎట్లా వస్తుంది ఈ స్టాట్స్ ఎక్కడి నుంచి వస్తాయి? ఎన్ మీన్, స్టాండర్డ్ డివియేషన్, మీడియన్, మినిమం, మాక్సిమం. హౌ we can get these stats?
Proc means.
Right, proc means you need to use the proc means processor, okay, an age variable. And then this is the sex variable. Sex means, okay, how many females, how many males we have. So out of, okay, for example, let's assume we have the 100 subject, there we'll have the randomized for this treatment 25. So out of 25, how many subjects were the male population, how many subjects were the female populations, okay? So let's assume that the 10 is female and then 15 is the male. So out of 25, this is the 10, okay? 10 divided by 25 into 100, what is the percentage? Okay, and then here the 15. Okay, so some 66, 44, some I'm not sure. So the respective percentage will come here. Okay, so and remember, okay, this is the floating values. In the percentage, sometimes we need to show the 2 decimal places, sometimes 1 decimal places, sometimes only the integer value. If you can see, this is only integer value. So here we are showing the percentages with the 1 decimal places. Okay, should remember. And then this is the categorical starts. Okay, which is nothing but categorical counts. How we are getting these counts? So here we need to get the continuous starts. Now we need to get the categorical counts for the sex variable. How we can get? How we can get? For example, simple, we have the SAS class. So there we'll have the 9 female and 10 male subjects, I think, yes, right? Out of 19. So how you are find the 10 males and then 9 females? How you can make sure that how you will get that counts? ఎట్లా వస్తాయి కౌంట్స్?
Proc frequency.
Yeah, that's what, right? Proc freak, we can use the proc freak and then it will give the frequency, how many times it occurs. That's what, right? This is the basic things, okay? If you can, we did not find these things also, it would be really difficult. That's what I keep on saying, that please practice SAS. I'm not sure how you people practice the SAS. So here the race value, again, is a continuous stats, and then we can use, sorry, categorical counts. If we can use that the proc freak or the proc SQL, also we can use that. In the proc SQL, you can use the count or distinct counts. It depends on the requirement. So this is the ethnicity. Okay, and then here height and weight and then BMI. So these are the continuous stats, so the same thing which we can get that. Okay, so these are the units which we need to mention in the bracket. Okay, so this is the category and then this is the particular stats. So if you can see this, what is the BMI, body mass index, we have mentioned this one. Okay, okay, so we can the summary of the number of person subjects who had relevant to medical history safety analysis set. Okay, so if you can see this here, they mention the safety analysis set. What is the safety analysis? SAFFL. What is the safety analysis flag? We have discussed in the ADSL, right? Can anyone, what is safety flag? What happened? No one remembered the safety population flag definition? I have explained multiple times and then I also said that this is a very, very important flag definitions. But you people are not. Okay, anyway, I'll complete my part. It's up to you. So the who have taken at least one dose of drug administration, then we can call it as a safety flag. Okay. So this is the summary of the number of percentage subjects who had relevant medical history. So the particular relevant medical history of this study. So the childhood asthma, who had which of the subjects will have the childhood asthma? The subjects counts we should represent it here. Okay. So then the same by your particular randomized treatments. Okay. And then here, if you can see the Medra, which kind of Medra version we have used, then we need to represent in the TLF. This is a summary of number of subjects who had at least one adverse event in any category, safety analysis. Okay. So this is the summary of adverse event table, and then the safety flag is that we need to use it. Okay. So if you can see the NEA means how many subjects got the adverse events. Okay. For let's say that we have the 100 subject, there we'll have the each and every category, we have the 25, 25, 25. So the out of 25, here how many subjects got the adverse events. So out of 25, then let's assume 20 subjects are the adverse events, then we can put the 20 here, and then 20 divided 25 into 100, so 80% will get it here. Okay. So any AE with outcome with the death. Okay. So out of adverse event, if there are any subjects is death, due to adverse event subject got died, then that subject count represent here. So any ASA, the serious adverse event. Okay. So including death. Okay. So which are the serious adverse events? How many subjects are that counts we should represent here. So any AE leading to discontinuation of IP. Okay. For example, this meaning if the subject is got adverse event, due to that subject got discontinued from the treatment, not from the study. So principal investigator stop the treatment for that particular subject, that we can count under here. Okay. So then if you can see the title, footnote, they mentioned subject with multiple events in the same category are counted only once as the category